I'm just going to hijack my old diagram because my circle is so beautifully drawn. You may like to draw another one, just a small one. This one's not going to be as complicated as the previous one. This circle is now, I'm defining it as the unit circle, okay? So it has a radius of 1. So I'm going to pop a 1 in there, okay? Now, off of this circle, I'm going to draw a line that will give me a triangle, which is where my tan theta and sec theta are going to find their names, okay? Not that complicated. So being that I've sort of used up the top half of the diagram, I'm just going to use the bottom half down here. Okay, so if I join up triangle OAQ, right, in triangle OAQ, okay, by the way, just as a side note, whenever you make any statements about right-angled triangles, which I can now say this is because I just proved that it's a right-angled triangle, and you say, oh, sine this or cos that, and you have some ratio, you should state what triangle you're talking about, okay? Because more often than not in the questions you're going to encounter, you have multiple triangles flying around, right? So if you want to reference a ratio within a triangle, you should say which one, okay? So in this triangle, OAQ, I'm going to name that angle at the center, I'm going to name it theta, okay? And then I'm simply going to have a look at what tan and sec are in this triangle, okay? So let's do tan first, it's easy. Tan theta, okay? Which sides am I looking at? I'm on opposite, right? Opposite on adjacent. So it'll be AQ on OA, right? AQ on OA. But this is the unit circle. This is the unit circle. So therefore, OA is just 1, right? So just rephrasing this, I can say AQ equals tan theta. Well, what is AQ? Answer, AQ is the tangent to the circle created by this angle. Right? If I were to just draw another one for you, right? Here's, let's see, let's do something like this. Okay? If I put up for you, okay, here's a point, right, on the circumference. Okay, give me an angle, right? Like say, okay, that's a pretty wide angle in there. Okay, let me make a narrower one. Okay, let's choose a theta like say 2 degrees. Okay, that's really nice. I'm gonna get 12 just to make it a little. Okay, so if I go like that, let's call that 12 because I can't draw 2 degrees. Okay, all right. I'm gonna have a line from here, the tangent, up to when it collides with that where that angle has been formed, right? Then this length here will be tan 12. It's the length of that tangent. Okay. Clearly, I could go off in the opposite direction as well. It would just be double, right? But the important thing is it's that length or some portion of that length. So really, tangent, gets its name from the tangent to a circle and its length for a given angle. Okay, so where is sec? Now, sec is a reciprocal function, SEC. It's 1 over cos because the third letter is. Okay. So therefore, I'm going to investigate cos. Let's have a look at it. In the same triangle, cos theta is equal to its adjacent on hypotenuse, right? So it's OA adjacent over OQ. Good? Yeah? Now, I already stated that OA is just 1. So if I rearrange this just a little bit, right, being that that's 1 on OQ, so if I make OQ the subject, OQ is 1 on cos, which is sec. Now, what is OQ? And the answer is, just like this is the tangent I get from such an angle, right? OQ, let me get another color. OQ is the secant, right? It's a secant because it cuts right through the circle. It's not tangent to the circle, okay? So here, right, see how I've got that 12 degrees there, right? Well, this length over here will be the secant formed by a 12-degree angle. That's it.